Hey, before we start today's lesson, I want you to do a few warm-ups. So let's start with these two problems here from what we learned last time and what you know about circles. I want you to work these out and see if you can answer these two questions. Then I'll go over them. So pause the video, and then I'll add a couple other questions up here, and we'll just do some warm-ups, okay? So take a look at these, pause the video, and go ahead and answer them. Okay, this first question right here, what is wrong with this picture? Well, hopefully you notice that the radius was 16, which means the diameter would then equal 32 centimeters. The diameter is the longest chord. Every time. So, the red chord must be less than 32. Okay, 32 centimeters. So hopefully you got that one. Now it says that AB is 17. Find AQ. Well, remember we had the theorem that said that any perpendicular to a chord bisected that chord. So that means that this over here would be 8.5 centimeters, and this would also be 8.5 centimeters over here. Okay, so AQ, 8.5 centimeters. All righty, let's look at a couple more problems. Let's have you do this one here first. So go, the diameter of the circle is 56 feet. TV is 42 feet. TS is 30 feet. RS is 12 feet. UQ is half of QR. Find the perimeter of QRSTU. All right, I'll let you pause the video here and figure that out. Okay, so let's see. What do we know here? We know that the diameter is 56, which means the radius is half of that. So this is a radius, it's 28 feet. So we know that. Let's see. We know that TV is 42 feet, which means that this is 21 feet, and this is also 21 feet because that's a perpendicular, so it bisects that. We know that RS is 12 feet. That's just given to us over here. Okay, we know that UQ is half of QR. Okay, so QR is 28, so that means this is 14. And let's see. Ooh, that leaves us with ST. Oh, ST is 30 feet. It's right there. Okay. So now we can find the perimeter. The perimeter is going to be 30 plus 12 plus 28 plus 14 plus 21. So this is going to be, this is 40, 70, 84, 105. 105 feet. Double check that. 42, 52, 62, 70, 84, 94, 104, 105. Yep, there we go. Okay, so hopefully you got that. Don't want any stray stuff over here. Whoops, what happened? There we go. All right, what have I got left here? Go ahead and take these three. Yeah, I don't know if I can fit that one. So go ahead and do those three right there. Pause the video, jump back on and see how you did. Okay, so I do know this. I know that this is a central angle. And so its intercepted arc, which is x, is equal to it. So this is 117 degrees right here. I know that a complete circle would be 360 degrees. So 360 minus 117 That'd be 243. So this is 243 degrees, which implies that its intercepted arc, which would be y over here, is also 243 degrees. So x is 117, y is 243, z is 243. Okay, look at number 5 here. So the blue angle is a central angle, which means that its intercepted arc is the same number of degrees. So this is 38 degrees right here. So that's x. And then the green angle is a inscribed angle, so it's always half of its intercepted arc, which means that it must be 19 degrees. Okay. All right, over here we're going to find x and y. So actually the easiest thing to do is to find y. Because this is perpendicular, so it splits the chord in half. So y is 3 inches. Okay, it's the same as this one over here. And, oh, I think I'm missing some information here. Yeah, there's some information missing here. So, I think I was supposed to say on here that this chord was the same length as this chord, which means that x would be the same as that right there, so that'd be 4 inches. Okay, so my mistake on that one. Okay, what do we got under here? Last question. Go ahead and take a look at this. OB is 20 inches. And find the measure of arc AB. And I'll let you pause the video and go figure that out, and then jump back on here. Okay, so here's what I know. I know that OB is 20 inches, and I know that OD is 20 inches. Okay, because they're both radii. That means OA is 20 inches, and that means that OC is also 20 inches. Okay, so these two triangles are congruent by side, 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 which means that, let's see, what else do I know? I also know that this angle right here is 62 degrees because it's the same as its intercepted arc right here. And I also know that these two angles have to be the same by CP/CTC, so that means that this has to be 62 degrees, which means that the arc has to be 62 degrees. So arc AB is 62 degrees. Okay. There you go. So hopefully you warmed up your brain pretty well here. Let's talk about tangent properties. Okay, a tangent to a circle is perpendicular to the radius drawn to the point of tangency. Okay, so what that means is I have this tangent line. It comes by. It just kisses the circle right here at point T. That's the point of tangency right there. If I draw a radius from the center to that point of tangency, that will always be a 90-degree angle every time. Okay? All right, so that's a nice little theorem that'll come in handy a few times. Hypotenuse leg. So we've talked about this actually already. If the hypotenuse and any leg of one right triangle are congruent to the hypotenuse and leg of a second triangle, then the two triangles have to be congruent. Okay, so basically what this says is if I've got a right triangle, okay, and I've got another right triangle, and I know they're right triangles, so that means that this is a 90-degree angle right here, okay, and I have the hypotenuse equal to the hypotenuse, and any leg congruent to another leg, those two triangles have to be congruent. Okay, this is one case where it's side-side angle and it works. Remember we talked about you could have the big side, then the little side, then the angle. That works, but the little side, then the big side, then the angle does not work. Okay, so this is no good right here. But that one is. Well, this is big side, little side angle. So There you go. Hypotenuse leg. Okay. Tangent segments to a circle form a point outside the circle. What does that say? Tangent segments to a circle from a point outside the circle are congruent. Okay. So what that means is I've got this circle, and I pick some random point out here outside the circle, and I draw a ray from that random point on both sides of the circle here. Okay? So it's tangent here at the point of tangency is A, the point of tangency here is B. Okay. So RA is tangent to circle O at point A. RB is tangent to circle O at point B. And I got to prove that AR is congruent to BR. Okay? So the first thing that I do is I go ahead and I draw segment OR. Okay? So I go from the center to that random point out there. And that's just, I can do that. That's just called construction. I can just take a ruler and line up 2 points and draw a line between them. Okay, now what does that give me? Well, that tells me this. It tells me that OR is congruent to segment OR by reflexive. Okay, so I can go ahead and do this right there. Now, I also know that OA is congruent to OB because all radii of a circle are equal. Okay, so I know that's equal to that. Okay, I also know that that angle, what is that? Angle RAO is equal to 90 degrees, which is equal to angle RBO, because we had that theorem just on the previous page that said that tangent lines are perpendicular to the radii drawn to the point of tangency. Okay. And now I've got two congruent triangles because hypotenuse leg. Okay? So triangle RAO is congruent to triangle RBO. Let's see. Oh, what did I just do? Put this back over here. Let's erase my stray dot over here. Let's extend the page here and move this down a little bit. Okay, that's by hypotenuse leg. Okay, now if the two triangles are congruent, all of their parts are congruent. So that tells me that AR, what's going on here? There we go. Whoops, got too many lines now. AR is congruent to RB. AR is congruent to, actually I should say BR by CP CTC. Okay, so I proved that those two things are congruent every time. All right, what fun. Can't have fun like this in PE or history. All right, so A couple of statements here. Tangent circles are two circles that are tangent to the same line at the same point. They can be internally tangent or externally tangent. Okay, so these are tangent circles because both of them are tangent to the same line at the same point right there. This is internally tangent. This would be, they're both tangent at that point right there. Those are externally tangent. Okay, it's internally tangent because one circle's inside the other one. And so that's pretty obvious, I think. Okay, got a little assignment here for you. Have fun with that. I will see you guys later.